The world is bracing for once a decade phenomena in the Pacific, which has got the potential to impact India's climate not only this year, but also in the coming year of 2027. Hello and welcome to Unacademy. Welcome to the session where we shall be discussing one of the unique atmospheric events and phenomena, that is Super El Nino event. Now, this Super El Nino event is slated to impact the Pacific later part of this year and will have an impact over rainfall and overall the amount of aggregate rains received in India for 2026 and even in 2027. In this session, we shall be taking a look at what is this Super El Nino, how is it different from a regular El Nino, and why does a regular El Nino happen in the first place? What will be the impact felt over India, the Indian Ocean in particular? And why is it that India is expected to receive one of the driest second half in the past decade? We shall also be taking a look at the multiple choice question, a prelims type multiple choice question at the end of the brief discussion. Take a look at that question and do let us know what the answer is in the comment section below. Now, as you can see, various international news headlines from Washington Post to even the case of the scientific journals to even our domestic newspapers, they are carrying news stories about the event of a Super El Nino. Now, this Super El Nino is a phase in the entire Pacific, which is ENSO. ENSO basically stands for El Nino Southern Oscillation. Now, this is a kind of a climatic oscillation which is observed in equatorial and southern Pacific Ocean during the winter months of northern hemisphere, that is in general the months of October, November, December, January, February is when these events they tend to peak. Now, as you can see with the help of the animation here, that this ENSO does involve three different phases. You have a neutral phase, which is the case of a normal Walker cell. You have the case of a La Nina, where India tends to receive higher than average expected rainfall. And you also have the case of El Nino, which is associated with reduced rainfall in India. Let us understand these conditions and then we will understand what is this Super El Nino. But before we come into those conditions, an important announcement for all of you. Now, in an academy's history, we have come up with the lowest and the most lucrative price offer for all of you at 16,999. The preparation of civil services is not a dream anymore, but is a reality. Now, if you want to ensure that your preparation is done in a timely manner, your syllabus is completed in a timely manner, do become the part of one of the best teams in the country and ensure that you take the right step in your civil services journey. Use the code IAS English, avail the offer tonight, and get a flat 60% off with free extension up to 6 months. Now, having said that, when we talk about these ENSO circulations, these are what are referred to as atmospheric ocean teleconnection. That is, whatever happens in the oceans influences the atmosphere as well. Now, why does it happen and how does it happen? So, here in this image, you will observe the heat distribution in ocean. Now, oceanic areas, they receive heat from the sun. It is the solar insolation, which is the prime source of heat, particularly in the tropical and the lower latitude regions. Now, this solar insolation will heat up the surface water to the maximum. And the water temperature tends to reduce as you move into the lower levels. You will have much cooler waters here. Now, this is the same phenomena which is observed in the Pacific, which is the largest ocean in the world. Now, to exaggerate the issue, in the region of the Pacific, you have very strong wind movement also, which is observed. Now, this wind movement, why is it strong? Because in general, over the oceans, the frictional force is very less. So the winds tend to become, anyways, very powerful. Now, these winds, when they move, they tend to drag the surface water along with them. So, think about it, the warmest surface water will be dragged by the winds. That means in these areas, the cooler subsurface water will emerge to the surface, impacting the sea surface temperature. So the winds impact the sea surface temperature in two different ways. How? For example, in a region, let's suppose you have onshore winds. These onshore winds will pull the warm water along with them, the warm surface water along with them, and will keep on dumping them and pushing them in the subsurface region. This pileup of warm water which happens, this creates a condition of higher sea surface temperature. Higher sea surface temperature. Now, this higher sea surface temperature is generally associated with the condition of low pressure. A low pressure zone is created. Whereas, if you have offshore winds, in the case of offshore winds, the opposite happens. What is the opposite? The warm surface water is dragged away. And that is where the cooler subsurface waters they emerge on the surface. Now, this brings nutrients up to the surface as well and induces greater phytoplankton population, thereby benefiting the fisheries in the region. But in this area in particular, you will observe that as the cooler subsurface waters emerge, it lowers the sea surface temperature. Lowers sea surface temperature. And at this low temperature, there is a comparative high pressure zone which gets created. So that is how the winds in itself creates differential temperature at the ends of the ocean. Now you observe the case of the Pacific with the help of this animation. Now, in the case of the Pacific Ocean, in general, the trade winds they move in a direction of east to west. So here also, the trade winds they are moving in general in a direction of east to west. So you can imagine they are dragging all the surface water along with them, and all the warm water is accumulating here. Meanwhile, there is upwelling in this region, and colder subsurface water emerges. This creates a low pressure region, this creates a high pressure region, and a circulation is thereby achieved. This is what is referred to as the normal cycle, the normal or the neutral phase of the ENSO, the neutral condition of ENSO, what is also a normal Walker circulation. Now, oftentimes, this phenomena tends to exaggerate. Here, you will be able to observe with the help of the animation that the satellite imagery of how the winds are dragging the surface water in the region of Western Pacific, that is in the region of Australian coastline, and all that warm water pool is creating a region of intense low pressure. It is also creating a piling up of water which the winds are able to keep afloat. Mind you, when I say piling up of water, so here basically what tends to happen is that the water gains a height gradient of around roughly 8 to 10 centimeter. The height increases. And that height gradient is maintained by the winds. Which winds? The trade winds. Over a period of time, that can intensify into La Nina conditions as well. But sometimes these conditions revert, they become the opposite. And that is when you have El Nino. In order to understand El Nino phenomena in simplest of the terminologies, look at this fan and bucket example. Now, here, what you see in front of your screen is basically a simple science experiment. You have a fan and you have a bucket which is full with water up to the brim. Now, the fan continues to blow air, right? Now, this air blown by the fan that will push the water at one end. So much so that the water will start spilling over as well. But the moment you switch off the fan, what will happen? The wind velocity or the wind speed moves. Will the water retain its piled up shape in this region? No, the water tends to flow back and maintain its normal position once again. This is the same thing which happens in the case of the Pacific Ocean. How? So imagine this to be the case of the trade winds. Now, these trade winds, if you imagine this to be the region of Western Pacific, that is Australian coastline, and this region to be Eastern Pacific, that is the Peruvian coastline, right? So the trade winds have helped accumulate, or the pile of water is created in the region of Western Pacific. And eventually, you will observe that the moment the trade winds they become discontinuous, the water tends to flow back. So what happens in the region of the Pacific is, in certain years there is excessive amount of heating. The Pacific starts to heat up, right? When the Pacific starts to heat up, then all this piled up water starts flowing back. So piling up of water is very high under normal circulations, even higher during the condition of La Nina. And after that, if there is a discontinuity in the trade winds, all that piled up water tends to flow back, right? Now, last year, a weak La Nina started to develop. Now, the Pacific has been getting heated up. And as the Pacific has started to heat up, that is when the trade winds become discontinuous. So, heating of Pacific, okay. Now, this heating of Pacific leads to weakening of the trade winds, weakening of trade winds, the trade winds which were supporting all the piled up water. Now, the weakening of trade winds leads to flow back of water. Now, this flow back of water means that all that water starts coming up in this region, right? And that is a westerly movement, that is west to east movement, which is observed in the water. So, this is when an El Nino event is created. But sometimes, once every decade almost, or once every 2 to 3 decades, you have an event which is known as Super El Nino. Now, in 2026-27, the El Nino event, which is going to be initiated, is expected to be the strongest in the past century. Before this, the prior Super El Nino events which have occurred in 2015-16 and so on. Now the impact is manifold. Here, with the help of the satellite data, you can observe that how the superheated warm water is accumulating already in the central and the eastern portion of the Pacific Ocean. So a super El Nino acts as massive planetary heat engine. What it does, releases vast amount of stored oceanic energy into the atmosphere and significantly alters the global jet stream pattern. It can impact the temperature in Europe, North Atlantic, Indian Ocean, Indian subcontinent, everywhere. The impact is manifold. But what makes an El Nino a super El Nino? How do we calculate that? So, that is basically calculated with what is referred to as a sea surface temperature anomaly. Sea surface temperature anomaly. Okay. Or what is also referred to as a Nino Index. Now, how is it calculated? It is basically calculated based upon the temperature difference in between the both ends of the Pacific Ocean, just like your Indian Ocean dipole. Okay. Now, this sea surface temperature anomaly, if let's suppose it is in negative, negative means that Western Pacific is warmer than Eastern Pacific. Western is warmer than Eastern. Than Eastern. Now, if that is the case, in that particular situation, you will observe that a La Nina event is initiated. La Nina event is initiated. Or a neutral cell also. Okay? Sometimes. But if this is in the positive territory, that is, Eastern Pacific is warmer. If let's suppose this is positive, that means Eastern Pacific is warmer. Then you have the case of El Nino. Now, El Nino is triggered when the sea surface temperature anomaly is in the positive territory. But in certain cases, When you have the sea surface temperature anomaly more than 2, that is, the eastern Pacific is warmer than the western Pacific by more than 2 degrees Celsius, then a super El Nino is created. Now, this can initiate a very strong climatic circulation, and the atmosphere, the jet streams, everything will be disturbed. So, always remember the sea surface temperature anomaly greater than 2 is going to initiate a super El Nino. Okay, so that is what is being expected later part of this year, which is going to be carried forward in 2027 as well. Now, how does it impact India? So, as you can see, this is the condition of super Nino events when they have happened. So, they have happened once in 1983, once in 1998, once in 2015-16, and now in 2026. So, once every decade, that this is that kind of a phenomenon. That is why it is very important for your exams as well. Now, whenever this tends to happen, you have warmer than average temperatures in the region of eastern and central Pacific. But what is interesting is you have colder waters in Indian Ocean and northern Atlantic Ocean. You have cooler waters. Now, cooler waters in northern or in Indian Ocean, how does it impact us if you have colder waters in Indian Ocean? So, whenever we say monsoon, monsoon is carried by the winds which come over to the Indian subcontinent. If you take a look at the background map here, monsoon winds basically they will follow a trajectory like this. They come over to Indian subcontinent. Now, if you have cooler waters in Indian Ocean, colder water in Indian Ocean, what is the implication of that? That in general the rate of evaporation massively reduces because evaporation is high when you have warmer waters, isn't it? Now, when the rate of evaporation reduces, the moisture carried by the winds will also reduce. Carried by winds also reduces, right? Now, this moisture carried by the winds, when it reduces, that means these are the winds which come to India and bring monsoonal rainfall. Overall, the amount of rainfall experienced in India also tends to reduce. So, that is the teleconnection in a way between Indian Ocean and the Pacific Ocean. And that is how, in Indian subcontinent, the amount of rainfall created by the Super Nino events that will reduce. You can see even in the northern Atlantic, it will have colder than normal waters. That means even the European region can expect heat wave conditions because there also rate of evaporation will reduce because of colder waters. Now the westerly winds which are prevalent there, they will carry lesser amount of moisture to the region of Europe because lower rate of evaporation, hence lesser rainfall in Europe, and that means greater heat wave conditions. Now, what is the overall implication that we will experience in India or that is to be expected in India? First of all, in terms of agriculture, we will have a reduced Kharif crop yield, isn't it? For example, the rice, the paddy cultivation, India is the largest rice producer in the world. Export markets are dependent on it. There, the amount of output will be less. Soil moisture deficiency will be observed in majority of the parts of central India, and as a consequence of that, multiple other crops such as onions, etc. There is an increased probability of the crop failure. Then water availability and water security. You will basically have lower reservoir levels, groundwater stress, water scarcity will be observed, and that will always impact the vulnerable and the poorer population with much greater amount. And then you will also observe the condition of heat waves, whereby basically lower cloud cover means temperature will be higher and hence heat waves will also be associated. So, what have we seen till now? We have basically seen what is the case of a normal neutral water circulation. why it tends to happen. Sometimes it does develop into La Nina, but why does an El Nino event develop? And what is the condition of a Super El Nino? Super El Nino basically develops when you have the sea surface temperature anomaly, which increases by more than 2 degrees Celsius. And thereby, we have also seen the impact in Indian Ocean, North Atlantic Ocean. There will be impact on the jet stream movement as well, and reduced rains in India. Let us take a look at this practice MCQ. Do let me know what is the correct answer in the comment section below. Consider the following statements regarding Super El Nino. These are associated with warmer than normal waters in Western Pacific, oftentimes observed with a Nino index of less than 2. They are associated with cooler waters in Indian Ocean and warmer waters in the Atlantic. Do let me know what is the correct answer in the comment section. If you have liked the content of the video, please don't forget to share it with your friends, like the video, and subscribe to the channel. Till we meet again, take care. Goodbye. Thank you.